Okay, so here we're going to solve this system now. All right, that should be fun. All right, well, again, here we're using the substitution method, okay? I mean, here I said to use the substitution method. I know from my past experience teaching this course, some people already know the elimination method. I mean, that's okay, but really here I want to make sure that you guys know how to use the substitution method. It's just better, I think, to have more than one method in your repertoire. Excuse me, at your disposal. I think I pronounced the previous word wrong. At your disposal, in other words. Okay. All right. So from here, here's what I did. If what you did is slightly different, that's okay. So I got y in terms of x from the first equation, as you can see. You have x plus y is 4. Okay, well, let's get y in terms of x. That's what I did. So let's subtract x from each side. This is what we get, as you can see. Right? We got y in terms of x. We get y is 4 minus x. Then we get the substitute not into the first equation. We substitute into the other equation, okay? Into the second one here. That's what I'm doing, right? So 4x plus 2y, that's going to become 4x plus 2 times y, which is 4 minus x. And so what that tells us is this part here is going to be 6. Because the second equation is equal to 6. You know, you have 6 on the right-hand side. Ready? Now, distribute. 2 we distribute, right? We get 4x plus 2 times 4 minus 2 times x, which is just 2x. So we get 4x plus, we get 4x plus 8 minus 2x. But if you combine like terms, that's where the 2x here comes from. So we get 2x plus 8. So 2x plus 8 is 6. And now let's solve for x. Let's solve for it. So what I did here, okay, again, if the steps you did were slightly different, that's fine. You know, as long as what you do is correct, I'm not going to mark it wrong. So we get 2x minus plus 8 is 6. Let's subtract 8 from each side. Doing so, we get 2x equals 2. Negative 2, excuse me. But we don't want 2x, we want x. So what do? Divide. We divide to get x equals negative 1. So we know what x is. What about y? Well, we know that y, remember, is 4 minus x, right? Well, so if we know x, we can figure out y. So we get 4 minus negative 1. That's what y is equal to, right? I replace x by negative 1. We get 4 minus negative 1, as you can see, which is 4 plus 1, which is 5. So the only solution here is negative 1, 5. And using our wonderful vocabulary, we can say that the system is consistent. And since there's only one solution, the equations are independent. That's what we get. Any questions on this? Remember, if you have a question, I can't see the chat. So use the hand raise feature. Or if you want me to see the chat, use the hand raise feature. Okay. Well, here, let's do the graphical method. Well, we can solve this by graphing. In this, basically what we do, we can graph each of these in the same set, in the same coordinate axes, you know, in the Cartesian plane. We graph both of these equations. And since the exponents, the powers of x and y, since their powers are 1, we're going to get straight lines. And what we want then is we want points of intersection. That's what the solutions are going to be. So when we graph these, where the graphs intersect, that's going to be a solution. And if there is a point of intersection, then the system is consistent. What could happen is this. What could happen though is this. If the two lines are parallel, meaning they never intersect, that's what can happen, then there are no solutions. So if the two lines never intersect, that is, if they're parallel to each other, there are no solutions. And then we say the system's inconsistent. What could also happen is the two lines could actually coincide, meaning they could overlap each other entirely. Well, in that case, the two lines have infinitely many points of intersection. That is, there are infinitely many solutions. The equations then are dependent and they're consistent. Okay. Now let me just go through how to actually graph using Desmos. Okay. I mean, with Desmos, it's a graphing software, and what's nice about it is it's free. So let me get the Desmos for you guys. With Desmos, right, you go to desmos.com. Let me do that. Let me share it with you guys, don't worry, so you can see it. The notes, again, I emailed to you, so you should have it in front of you. Let's see. Oh, yes, there it is. Here it comes. So it's coming up. Here's Desmos, okay? So again, I typed in www.desmos.com, okay? It's going to say login or sign up. You could make a free account if you wanted to. I mean, you don't have to. I mean, if you clicked on sign up, you can make an account with your Apple or Google account, either one. Or you could just make an account with an email address, either one. You don't have to do that for this class. I mean, it's free to do, so it's not. I don't think it'll cost you anything if you do it. No, I know it won't. I mean, if you do make an account, you could save the graphs you made. So what we do next is click on Math Tools. Then you'll see Graphing Calculator. You can also download this as an app onto your phone. I mean, I have it on mine. So we click on Graphing Calculator. As you can see, we got this. Okay, that's great. And what we do here on the left, these text boxes, well, now there's only one. You type in the graphs that you type in the equations that you want to be graphed. So if we typed in, for instance, from our notes, 2x minus y is 5, Desmos will graph it. What's nice is you don't have to get y in terms of x, with Desmos at least. If you click below, you see how the icon changes, the mouse icon that is? Click, you get another one. Well, let's type the other, other equation. You get 3x plus y equals 10. And you could see that the 2 points, they intersect, right? Only one, so there's one solution. And if you hover over that point, it'll tell you what that point is, which is 3, 1. Excuse me, get back to that. You could also zoom in by pressing the plus icon up here. See, zoom. You can also click and hold and drag like I'm doing here. And then you could zoom in. You can also get close. You can also zoom in. Well, not zoom. You can also click on the wrench icon here, and you can see you could change the interval for the x-axis. You know where your viewing window is. Same thing for the y-axis. Radians and degrees don't worry about. That's only when you're graphing the trig functions, and that you won't do unless you go into pre-calc, which is Math 105. Okay. We're not ready to do that though. But you can see you get the point of intersection, which is actually 3, 1. Right? Again, you can click. I mean, you can see it from the axis, right? Here's 3. Here's 1. Okay. Now you can click and drag till, okay, you may have to zoom out a bit. See, but you can see it's 3, 1. You may have to zoom out a bit, but if you zoom in also, you can see that you can see 3 and 1. So 3, 1 is the point of intersection. And we have about time flies when we're having fun. We have like less than a minute. But that's Desmos. If you do make an account, you could save the graphs that you make. Do you have to do that? Well, no, but you can. So next time what we'll do is, let me see. See, I did that slide. Yeah, I did those. Yeah. Okay, so basically a few slides we actually did. The next few slides, as you can see on the notes, they actually basically show what I just showed. So next time we'll start with example 5. So we'll start from here next time. All right, so let's stop now, I guess. So I'm going to stop this.